Hello everyone, thank you very much for watching my video today. In this video, we're going to talk about solving motion problems using parametric and vector valued functions. Okay, so we spent a lot of time in the first half of this, or if you took AB last year, or the first half of BC, talking about straight line motion, or rectilinear motion. But now, with this newfound knowledge we have with parametrics and vector valued functions, we can discuss motion along curved paths, which is good because many things in life don't follow straight lines. As an object moves along a curved path, the coordinates x and y of its center and mass are each functions of time t. Rather than use f and g to represent two functions, we write x of t and y of t, so our position vector r is in the form r equals x of t I plus y of t j. The nice thing about doing this is that it's very easy to use derivatives of the vector valued function r to find the object's velocity and acceleration. Remember that velocity and acceleration are both vector quantities having magnitude and direction. So, quick definition to start. If x and y are twice differentiable functions of t and r is a vector valued function given by r of t equals x I plus y j, the velocity vector and acceleration vector at time t are given by the following. The velocity, you just take the first derivative of x and y and multiply by I and j. And the acceleration, you just take the second derivatives of x and y. And the speed, we would just do the magnitude of the velocity vector, as you can see below. So let's jump into our first motion problem. Example 1, velocity, acceleration, and speed. A particle moves along a plane curve given by r of t. First, generate a rectangular equation that describes the particle motion. Okay, so we have here that x of t equals 3 sine t over 2, and y of t equals 3 cosine t over 2. Solving each of those, well, not solving, but just kind of rearranging a little bit, we get x over 3 equals sine t over 2, and y over 3 equals cosine t over 2. If we square both sides, we get x squared over 9 equals sine squared t over 2, and y squared over 9 is cosine squared t over 2. From our pre-calculus days, we remember that sine squared plus cosine squared equals 1, so therefore x squared over 9 plus y squared over 9 equals 1. Multiplying by 9, we get x squared plus y squared equals 9. Meaning this is just a circle with radius 3, centered at the origin. Part B, find the velocity, acceleration, and speed, and interpret the speed. So the velocity will just be our derivative of our position function, r of t, so r prime of t. So this would be 1/2 times 3, so 3/2 cosine t over 2 minus 3/2 sine t over 2. And don't forget to put in your I and your j. And our acceleration vector would just be the derivative of that. So it would be negative 3/4 sine t over 2i minus 3/4 cosine t over 2j. Speed then would just be the magnitude of the velocity vector. So the formula for that there is just root x prime squared plus y prime squared. So square root x prime squared plus y prime squared, which ends up being root 9/4 cosine squared plus sine squared, which of course is just root 9/4 times 1, which is just 3/2. So what does that mean? It means that the speed of this particle is always 3/2. C, show the particle's path on the graph to the right. Okay, well, we know that it's a circle. So to graph this, let's say we put in 0 for t. So 3 sine of 0, I, plus 3 cosine of 0, j. The point at 0 is 1 comma 0. So it would be 3 times 0, I, so 0, I, 3 times 1, j. So the first point there, well, first thing we should probably do is draw our circle. Back here we know it's a circle with radius 3. All right, technically the first point is right here, 0i plus 3j. All right, now the second point, let's pick another point. Let's pick pi for t. So 3 sine pi over 2 is 3 times 1, so 3. 3 cosine pi over 2 is 3 times 0, so 0. So this would be the next point that we just found right there, which means our direction of travel is going to be going this way. Finally, question D, find the velocity and acceleration at t equals pi. Draw the velocity and acceleration vectors in the graph. Okay, so velocity of pi would be 3/2 cosine pi over 2 I minus 3/2 sine pi over 2 j. So 3/2 cosine pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So this is 0i minus 3/2 j. So my velocity vector at pi, which my point was at 3, 0, there should be right there. So that would be, again, v of pi. Okay, and then my acceleration at pi would be negative 3/4 cosine pi over 2 I. Sorry, sine pi over 2. Copy that down wrong. And then minus 3/4 cosine pi over 2 j. So sine of pi over 2 being 1, so it would be negative 3/4 I. Cosine pi over 2 is 0, so plus 0 j. So my acceleration vector should be like that. Example 2, motion along a curve. Sketch the path of the object moving along the plane curve given by r of t, by the acceleration and velocity vectors at speed 0 and speed at t0 and t2. Sketch the velocity and acceleration vectors on the curve below. Okay. So first of all, let's just find all of our x's and y's. We'll just do this one at a time by putting all of these t values into here. Okay, I did this ahead of time, so I didn't have to waste time in this video. So I'm just going to copy down the points I got. 22, negative 5, 13, negative 4, 6, negative 3, 1, negative 2, negative 2, 1, negative 3, 0, negative 2, 1, 1, 2, 6, 3, 13, 4, and 22, 5. So if we plot those points, now obviously I'm not going to have the full graph here, but if we started with t equals negative 3, 6, negative 3 would be here, and then 1, negative 2, negative 2, negative 2, 1, so negative 2, negative 1. We did something wrong there. It should be 1, negative 2, negative 2, 1, negative 3, 0, 1, negative 2, 1, 1, 2, and 6, 3. The graph's going to look like this. So a parabola facing to the right almost. And the direction of travel is this way here. Okay? So now, find the velocity that would be 2ti plus j. So the velocity at 0 would be 0i plus j, and the velocity at 2 would be 4i plus j. So if I sketch those in there, so velocity at 0, when t equals 0, would be just j, so that would look like this. The velocity at t equals 2, that's when the point is at 1 comma 2, is 4i plus j. So technically that point's supposed to be right here, right now. 4i plus j would put it here, so that vector should look like that. Okay, and then the acceleration would be 2i plus 0j, so just 2i. So a of 0 would be 2i, a of 2 would be 2i. So my acceleration there, and my acceleration there. Okay, and then the speed at each of those points, remember we're using that formula right there, root x prime squared plus y prime squared. So for the speed at t equals 0, it would be square root of x prime squared, so 2t squared plus 1 squared. So it'd be root 4t squared plus 1. And if you put in t equals 0, the speed would be 4 times 0 plus 1, so it's root 1, so our speed is 1. So at t equals 0, speed would be 1. And then at t equals 2, if you put 2 in there, 4 times 4 plus 1, so root 17. So our speed would be root 17. Okay, example 3. Motion along a curve. We're with our calculators this time, so if you want to stop and get your calculator out. All right, the first thing we should probably do is change this into parametric mode. So go to mode, parametric mode, and in our calculators. All right, x1 of t is going to be e to the t, and y1 of t is going to be natural log of t. All right, so we have a graph that looks something like that. Let me change my -5. We're going to go -5 to 5 for t. Okay, so actually we can't go -5 to 5 because we can't do natural log of that, so we're going to start at 0. Go 0 to 5. Okay, so there's our graph. It says to sketch that here, so it's just going to go to the table and see if we get 1 comma 0, 2 comma 0.6, 3 comma, or sorry, at t equals 1, 2.7 comma 0. I kind of screwed that one up there, sorry about that. At t equals 1, we get 2.7 comma 0. At t equals 2, 7 comma 0.6. Somewhere around there. At t equals 3, we're at 20 comma 1.09, so we're right about there. So our graph should look something like this. Direction of travel going this way. Okay, so find the velocity and acceleration vectors and speed at t equals 1. So velocity We'll put that to the side for now. Our velocity vector would be e to the t I plus 1 over t j. So v of 1 is just ei plus j. Our acceleration vector would be e to the t I plus, this would be t to the negative 1, so negative t to the negative 2. So that should be minus 1 over t squared j. Our acceleration at 1 would be ei minus j. Okay, and then the speed at that point, so speed would be root e to the t squared plus 1 over t squared. So that's root e to the 2t plus 1 over t squared. So at 1, that would be root e plus 1. E squared plus 1, sorry. Root e squared plus 1. Which is actually what we're being asked to do again in D. So, all right, so C, sketch of velocity and acceleration vectors on your curve above to the right. So those two vectors that we just got, E is about 2.7. So remember the point we're looking at is 2.7 comma 1. That point, 2.7 right and 1 up, so it should look something like that. That would be our velocity vector. And our acceleration, 2.7 right and 1 down, so it should kind of look like that. So this is our V of 1 vector, this is our A of 1 vector. All right, so question E, what happens to the position, velocity, acceleration as t approaches infinity? Well, let's just take a look here. As t gets bigger and bigger and bigger, x and y are both going to increase forever. X is going to increase really quickly, y not so quickly, but it still will. The velocity and the acceleration vectors will approach infinity well for the x portion, but for the y portion, they're going to get closer and closer to 0. So the x portion of our velocity and acceleration will get bigger and bigger. The y portion will get smaller and smaller. Okay, example 4, motion along a curve again. A particle starts at rest from the point negative 1, 2 with acceleration vector a of t. Find the location of the particle at t equals 2. All right, so velocity is going to be the antiderivative, obviously, of our acceleration vector. And that's going to give us t plus c1i plus 2t plus c2j. That's our velocity function. But we know v of 0 is 0, 0. It was told it starts at rest, right? So when I put 0 in for t, I should get 0 plus c1 equals 0. So c1 equals 0. And 0 plus c2 equals 0. So c2 equals 0 as well. So my velocity function is just ti plus 2tj. Now we'll repeat that process. So my position function, we'll call it r, is the antiderivative of that. So ti plus 2tj dt. So that would be t squared over 2 plus c3i plus t squared plus c4j. All right, we know r of 0 equals negative 1 comma 2. So negative 1i plus 2j. So I'm going to set t squared, 0 squared. So 0 plus c3 equal to negative 1. 0 plus c4 equal to 2. So c3 equals negative 1, c4 equals 2. So now my r of t must be equal to t squared over 2 minus 1i plus t squared plus 2j. So finally, find it at 2. So r of 2 would equal to 4 over 2 is 2 minus 1. So it'd be just 1I. And then 2 squared plus 2 at 6, so plus 6j. So at t equals 2, the particle is at 1 comma 6. Okay, example 5, motion along a curve again. A particle with an initial velocity I plus j and initial position 1, 1 has an acceleration vector a of t. Find the location of the particle at t equals pi. All right, so the first thing we're going to do is write a velocity function. So I have v of t, and it's going to be the integral of a of t which is going to equal negative sine t plus c1i plus negative cosine t plus c2j. The initial velocity is I plus j. So that, what they're saying here is v of 0 is I plus j. So that means that this must be equal to 1 and this must be equal to 1. Both of those must be equal to 1 when t equals 0. So negative sine of 0 plus c1 equals 1, and negative cosine of 0 plus c2 equals 1. Sine of 0 is 0, so c1 equals 1. Cosine of 0 is 1, so negative 1 plus c2 equals 1. c2 equals 2. So now I can rewrite my velocity function as this, replacing c1 and c2 with those constants. Okay, now we're just basically going to repeat that process here. I'm going to move some things around here to save some space. All right, so basically going to repeat the exact same process that we just did. So now I'm going to write a position function. We'll call it r of t. And that is going to be the integral of v of t. All right, so it's going to be the integral of that. So that is going to be cosine t plus t, oops, I have to put cotangent t, I meant cosine of t, plus t plus c3 I plus negative sine t plus 2t plus c4 j. And that is r of t. We are also told the initial position is 1, 1. So r of 0 is 1, 1. Okay, so that means that when t is 0, this is 1 and this is 1. So we have cosine of 0 plus 0 plus c3 equal to 1. And then negative sine of 0 plus 0 plus c4 equals 1. Cosine of 0 is 1, so we have 1 plus c3 equals 0. Therefore, equals 1, sorry, so c3 equals 0. And then negative sine 0 is 0, so 0 plus c4 equals 1, so c4 equals 1. Apparently I should have saved a little bit more space here. Running out of space on this problem. All right, so then r of t can be written as cosine of t plus t I plus negative sine of t plus 2t plus 1 j. So So then finally, r of pi would be cosine of pi, which is -1, plus pi I, plus sine of pi, which is 0, plus 2 pi plus 1 j. So the point at t equals pi, the point is at -1 plus, oh my goodness, let me try that again, -1 plus pi, comma, 2 pi plus 1. All right, remember when an object is subjected to gravity, its position s above the ground is given by s equals -16t squared plus v sub 0 t plus s sub 0. That in mind, we can solve from some vector motion problems you may have done in the previous unit using parametric equations. A baseball is hit 4 feet above the ground and leaves the bat at a speed of 105 feet per second at an angle of 40 degrees to the ground. Question A says to write a vector that describes the motion of the ball. All right, so we have r of t equals, well, its x coordinate is just going to be 105. Well, actually, I'm going to write it as 105 cosine 40 t. Make sure the 40 is in parentheses, the t is not. So 105 cosine 40 ti plus -16t squared plus 105 sine 40 t plus 4 j. All right, so let's make sure we understand where we got those numbers from here. So the 105 cosine 40 and the 105 sine 40, that's the components of the vector given the 105 and the 40 from the problem. And this part here are from this equation. It's starting height and a -16t squared. I'll go with the height, the j. Question B says determine how high the ball goes. So what we're going to want to do is we're going to want to take the derivative of the y coordinate and see when that equals 0. Okay, so we're going to set, first of all, we're going to do y prime of t, and that's -32t. And then 105 sine 40t, the derivative of that is just 105 sine 40, and the derivative of 4 is equal to 0. We're going to set that equal to 0, so I want 32t equal to 105 sine 40. Now, that's not really something we can solve for off the top of our heads, so instead of doing that, let's just set this equal to 0. And solve via the calculator. So we can graph that. You don't even have to be in parametric mode to do this. You can just be in regular mode to do this. I already forgot the equation. Oh, I'm still in parametric mode. Let's go back to function mode. -32t plus 105 sine 40. Make sure you're in radian mode as well, which we are. Okay. I'm going to go 0 to let's go 20. And we'll see with that. Okay, so we got our answer there, it looks like. Second, calculate 0. Bear with me as I scroll over. All right, looks like I'm getting 2.449. Oh, that's not the right answer here. Let's try that again. No, that's what it's giving me, 2.449. Okay. I didn't think that was right, but it looks like we're getting it twice. So 2.445 seconds. C, there is a 12-foot high fence 325 feet from home plate. Is the ball a home run? All right, so what we want to know here is 325 feet away, so that's the x coordinate, will the ball be 12 feet or higher? Okay, so we want to know, first of all, when the ball gets to 325 feet, what would the time be? So we're going to set the x coordinate, which is 105 cosine 40 t equal to 325. All right, so t equals 325 over 105 cosine 40. Go back to the home screen for that. So we got 325 divided by 105 divided by cosine 40. We should be in degree mode for this. That's why my answer for the last one looked different. We should be in degree mode because 325 and 40 degrees. All right, so that's why my last problem looked different. I'll go back and fix that in a second. So let's try that again. So this number divided by cosine 40. 4.041. seconds. So we want to know what the height will be at that time. So we're going to put that time into my y coordinate. So negative 16 times 4.041 squared plus 105 sine 40 times 4.041 plus 4. I'll put the 4 there. And if we type all that into our calculator, let's see. This would be 4 minus 16 times answer squared plus answer times 105 sine 40. The height would be 15.491 feet. So is that bigger than 12? The answer is yes. That is a home run. All right, now I'll go back and fix part B. Now our graph is in degree mode here. The 0 is 2.109. That sounds more familiar. 2.109. Sorry, I was in reading mode. Just used to that. But for these problems, when the angle is given in degrees, we want to be in degrees. All right, example 7, application of motion again. Water from a fire hose is discharged at a maximum rate of 80 feet per second from a height 4 feet from the ground. Firefighters can get 25 feet from a burning building. They shoot the water from their hose at an angle of 45 degrees to the ground. What is the maximum height the water can reach? All right, first of all, let's write an equation for R. Okay, so it's going to be 80, that's the feet per second, cosine 45 t I plus negative 16 t squared plus 80 sine 45 t plus 4 j, 4 being the height that the hose is above the ground. All right, so we want to know the maximum height. So again, what we're going to do is take the derivative of y. So y prime would be negative 32t plus 80 sine 45. Set that equal to 0. And we can go ahead and solve that. Actually, we don't even need a calculator for that, do we? We don't need a calculator for that. Let's try this without a calculator first. Negative 32t. Let's go 32t equals 80. Sine 45 is root 2 over 2. So t equals 40 root 2 over 32, or 5 root 2 over 4. Now, if I wanted an approximation for that, 5 root 2 over 4 1.768. All right, so, but the question isn't asking when will it reach the maximum height, it's asking what is the maximum height. So now we're going to find y of that number. Actually, I'm better off probably using the whole number here. 5 root 2 over 4. So we're putting that into our y-coordinate. So negative 16 times 5 root 2 over 4 squared plus 80 sine 45 times 5 root 2 over 4 plus 4. So I'm just going to store this in x. Negative 16 x squared plus 4 plus 80 sine 45 times x. 54, what's the unit here? Feet. The building completely burns down. The firemen are shooting water on the wreckage. How far into the wreckage can the water reach? So essentially we're asking for when the y value will be equal to 0. Okay, at the time that happens, what would our x value be? So we want to know when will this equal 0. Okay. I'm going to use the graphing capabilities to do that. It's negative 16t squared plus 4 plus 80 sine 45. Actually, let's just make it easier on ourselves. Sine 45 is root 2 over 2, so that'd be 40 root 2 x. All right, so when will that be 0? Let's go ahead and calculate our 0. $3.605 is when it would hit the ground, how far it reached. So we're going to put that number into x. So it's going to be x of 3.605. So 80 cosine 45, so that'd be 40 root 2 times 3.605. 60488. 3.60488 times 40 times root 2. And we get 203.923 feet. Okay, last one here. Projectile is fired from the ground level at an angle of 10 degrees to the horizontal. Find the minimum velocity necessary if the projectile is to have a range of 100 feet. All right, so first of all, let's again start with writing our position function. So it's going to be v sub 0 cosine 10 t I plus negative 16t squared plus v sub 0 sine 10 t j. All right, plus 0 because it's at ground level, so we have to write that down there. All right, so what we're going to do here is we want to make the x coordinate be 100 at least. They have a range of 100 feet here. So what we're going to do is we're going to set the y coordinates equal to 0, and solve here. So v sub 0 then would be negative 16t squared over t sine 10. Which we could reduce down to negative 16t over sine 10. All right, we want the x-coordinate to be 100. So I'm going to set the x-coordinate equal to 100. So then v sub 0 would equal 100 over t cosine 10. So now we can set those two equal to each other since they're both equal to v sub 0. So negative 16t over sine 10 equals 100 over t cosine 10. Okay, and then if I cross multiply, I would get negative 16t squared cosine 10 equals 100 sine 10. And now we can get t squared equals negative 100 over 16 tangent 10, which I can reduce down to 50 over 8 or 25 over 4. So then t would equal the square root of that. Get my calculator out one more time here. Negative 25 over 4 times tangent of 10. That's not right. What did we do wrong here? Let's go back and find our mistake here. Oh, I can see it already. This is positive 16t squared. Let me add that over. Okay, let's try this again. So 25 over 4 times tangent 10, square root of that answer, 1.0498. Okay, so that's our time there. So if you could put that back into either here or here, it doesn't really matter to get your initial velocity. So our final answer here, v sub 0, let's put it into the second one there. So that times cosine 10, and 100 divided by the answer. $96.727. What's the unit on this one? I guess they don't give us units. Feet per something. We don't know what that is though. But that's it. That is our velocity. Our minimum velocity, negative 96.727. All right. Thanks for sticking with me today in this long video. I appreciate it. Hope you learned something, and we'll see you again soon.